All right, so here's just in case. He's firing his air rockets. He's got a little platform here, right? He's shooting the air rocket, and of course the air rocket's going to hit this light tower, right? Okay, so the rocket goes up, right, and then it comes down. Somehow it comes down on top of the light tower, right? Never mind the discontinuity here, right? So it goes up, it comes down, lands on the light tower. And the light tower is 32 meters tall. So this height here is 32 meters. Okay. And I think what we want to do is in this one, figure out what time is it in the air and with what velocity it strikes the tower. And I think I'm going to do this one first. Okay. I'll just show you why. Okay, so let's look at this thing, right? He fires it up. Oh, we know the velocity. That's good. Okay, so let's go from the ground to the tower. Oh, what is that? Ground to the tower, right? S-U-V-A-T. A is, of course, negative 9.81. There you go. All right, and then our initial velocity is positive 34.5. Because he tells us that, right? Our displacement is 32 meters. Okay, and at this point, kids want to say, well, if it goes above the tower and then comes down, it goes a greater distance, and that is true. But remember that displacement is not distance. Okay, displacement is the net change in position from beginning to end, and that I would maintain is, even though it goes above and down, the net change in position is 32 meters. Okay, so this is, we find out whether you understand displacement or not. Now, if I wanted to solve for t, I could set up s equals ut plus 1/2 at squared. Okay, and I would actually get two roots. I would take the larger of the two roots, because the two roots would be, in other words, so I do the quadratic equation, right? The larger of the two roots is this time hitting the tower on the way down. The smaller, the meaning of the smaller would be when it passes the tower somehow magically on the way up, not striking it and then comes down on top of it, right? Okay, so we could do that. That's quadratic. Let's not. Let's find the final velocity here. Okay, so I'm going to use v squared is u squared plus 2as. So the absolute value of the final velocity is the initial velocity squared, so 34.5 squared, plus 2 times negative 9.81 times, what's our s? 32. Okay, so now we're set. Let's type this guy in here. Let's go square root of 34.5 squared plus 2 times negative 9.81 times 32, and then I do, forgot the square root, didn't I? Okay, let's draw the square root on this thing, right? There it is. Yeah, it's the square root of that, right? So I took the square root of both sides. Okay, here we go. Let's see, 34.5, is that right? Do I have it? I think I do. Let's see. So I get that V is, since it's an absolute value, right, I'm getting 23.72 roughly, right? Okay, that means that V is equal either positive 23.7, it's actually 715, or, right, negative 23.715. Now, normally in math class we just go, well, let's use the positive number. But remember that the sign here is the direction of the velocity. And if it's hitting the tower on the way down, right, if that's true, then it must be that the negative answer is the correct one to use. Okay, so the velocity we're going to use is this guy, negative 23.715. And I'm carrying extra sig figs because I'm actually going to use that number. Okay. Now we want to find the time, since we've been so thoughty about this, right? We know it's going down, right? We want to actually use just V equals U plus A T, right? We'll just plug this in. Negative 23, 715. Sorry, my pen's just being really slow here. Equals the initial velocity, so that's 34.5 plus negative 9.81 times the time, right? We're trying to find the time it hits the tower, right? Don't feel like you've got to answer these questions in the order they're asked. Just answer them any way you can. All right, so let's see. We've got to do math here, don't we? Okay. Okay, divided by 9.81. I'm doing math. All right, 5.934. Okay, so my t is right. So the time, we've got the time, we've got the velocity of impact. Why did we skip that middle one, right? The middle question was how high does the rocket go, right? That's going to require another SUVA. That's not ground to the tower, that's ground to the top, okay? So anytime you change those things, you got to sort of redo this thing, okay? But we did get that one, and we got that one, and then we'll do the ground to the top, okay? That'll be actually pretty easy.